5 NASA engineers recently discovered a planet orbiting a star 22 light-years away. We are calling it planet SSNTG. The planet happens to have a similar landscape to that of the arid Earth many millions of years ago. Therefore, we have further studied the planet and observed that it has tectonic plates with volcanic activity. Here are some of our findings.
We have some current visuals on the plates. They seem to all be bunched up together, comparable to a supercontinent called Pangaea, located on Earth some 200 million years ago. Another shocking discovery was that of water. Water has been found on planet SSNTG and is relatable to the Earth's ocean, Panthalassa, that existed with Pangaea. The plates seem to be diverging at the center of the cluster of plates, which is what is causing the expansion. Landforms on planet SSNTG consist of mountains at convergent boundaries and trenches located at divergent boundaries. Many landforms reside underneath the ocean, as well as with numerous dormant volcanoes and canyons. The crust is being stretched, forming small valleys on the surface. We identify this as being recent geologic activity occurring less than 50 million years ago. Some common rocks in the crust are granite, gabbro, basalt, gneiss, schist, amphibolite, sandstone, shale, and limestone. Many of the rocks seem to be relatively new, especially ones being found near an ocean ridge, similar to the Mid-Atlantic Ridge on Earth. This shows that new rocks are being created and that there must be a convection zone on the opposite side of SSNTG as it is not expanding. We have also located a mountain range towards the south of the western landmass.
Because of various evidences found on planet SSNTG, we know that plates there are dynamic. These findings include 1. Fossils of identical plants and extraterrestrial creatures are found on different sides of the supercontinent. 2. Rock strata of mountains on the north side of the supercontinent match with fragments broken off from the south side of the supercontinent. 3. Fossils of specific types of animals are found on opposite sides of the supercontinent. Though they are the same species, they seem to evolve because they have some changing characteristics throughout the different areas that they were located at. 4. Fossils of plants in significantly warmer areas are found in colder areas of the supercontinent. And 6. Stripes of magnetic material in the seafloor also provide strong evidence for tectonic theory. The stripes alternate between those with magnetic material oriented toward magnetic north and those oriented in the opposite direction. Seafloor spreading is a mechanism behind this phenomenon.
The amount of heat stored in a planet's interior comes from two sources: the energy of formation of the planet and the heat generated by the decay of radioactive elements. The thin, fragile plates slide very slowly on the mantle's upper layer. The sliding of the plates is caused by the mantle's convection currents, slowly turning over and over. SSNTG's layers are similar to the Earth's. SSNTG's crust is composed of several elements: oxygen, silicon, aluminum, iron, calcium, magnesium, potassium, and sodium. The crust is divided into plates that float on the mantle, the next layer. The plates are constantly in motion. Earthquakes occur when these plates grind against each other. Mountains form when these plates collide, and deep trenches form when one plate sides under another plate. The mantle is composed mostly of silicate rocks, rich in magnesium and iron. Intense heat causes the rocks to rise. They then cool and sink back down to the core. When the mantle pushes through the crust, volcanoes erupt. At the center of the planet is the core, which is two parts. The solid inner core of iron is surrounded by a liquid outer core composed of a nickel-iron alloy. The inner core spins at a different speed than the rest of the planet. This is thought to cause SSNTG's magnetic field.
Similar to Earth in the Permian period, planet SSNTG had a large convergent boundary on one side of the large landmass, and on the opposite side a large divergent boundary. 25 million years ago, planet SSNTG was in the process of connecting at all sides. Because of the impact of the land masses, it created many earthquakes and mountain ranges. Then a large asteroid hit planet SSNTG. The impact made a large crater on the supercontinent, and the impact also shifted the direction of the plates and switched the convergent and divergent boundaries, bringing planet SSNTG together. Therefore, with the divergent boundary now where the convergent boundary is, the supercontinent started to spread apart. Because of the divergent boundary spreading apart, rifts occurred. We have also found evidence to support the major contentions of seafloor spreading: eruptions of molten material, magnetic stripes in the rock of the ocean, and ages of the rock themselves. Rocks form when molten material hardens quickly after erupting underwater. These rocks show that molten material has erupted again and again along the mid-ocean ridge. Also, Matching bands of magnetic rocks were found on either side of the mid-ocean ridge. This displays the changes or reversals in magnetic field over time, much like the Earth. Samples from the seafloor were also brought up through pipes that were drilled. We determined the age of the rocks in the samples and found that the further away from a ridge the samples were taken, the older the rocks were. The youngest rocks were always in the center of the ridges, and the sediment cover is thinner near the ridge. Also, the rock making up the ocean floor is considerably younger than the continents, with no samples found over 200 million years old, as contrasted with the maximum ages over 3 billion years for the continental rocks. This confirms that older ocean crust has been reabsorbed in ocean trench systems, and that the seafloor spreading really has taken place.
So, based off our knowledge of Earth 200 million years ago, we predict that subduction zones will occur in between oceanic and continental crust, forming a volcanic range. When the eruption of the volcano occurs, we believe new small islands may form as well. We have already found evidence for the seafloor beginning to spread, and we think that did Pangaea. This one large landmass will eventually split apart into several different continents due to the convection currents and different densities present. Various types of landforms are formed: volcanoes, mountains, ridges, trenches, and faults.
Predictions of weathering and erosion. As stated in the law of horizontality, we believe that all rock sediments that are weathered and eroded will settle horizontally, the youngest at the top and the oldest at the bottom, which is supported by the law of superposition. There may be a presence of magma intrusions which come out from divergent boundaries, and according to the law of cross-cutting relationships, the intrusion will be younger than the rock it intrudes. We also predict that magma may break off parts of the rock and carry it in the inclusion, and based on the law of inclusion, the inclusion will be older than the intrusion. As the law of uniformitarianism states, further weathering and erosion will occur like it did before. We predict that with the process of the sedimentary rock particles and deposits of weathering and erosion in the future, winds will weather them in streams such as Alsi Nadi or Lazy River a few hundred miles away. Through the process of erosion, the particles will lead to the creation of canyons, deltas, plateaus, mesas, and buttes. Erosion by wind and water will create desert arches and sand dunes responsible for the creation of a canyon. Water also dissolves into the rocks to form karst topography, a landscape filled with caves, caverns, and sinkholes. Glaciers will carve out U-shaped valleys and deposit sediments that create features associated with the advancing and retreating of the glacier. And that brings us to the end of our mission. Though these are the only findings we'll be able to make so far on our trip to planet SSNTG, we hope to make other discoveries as amazing as this one and bring along even more people with us. Thank you for watching.